Good morning. I would like to welcome the teachers and students from the Monroe County Schools to our virtual field trip. Hi, my name is Joe Perlacki, and I'm the liaison at the University of Toledo for businesses, for the scientists, and for the education community. And basically, that's what we're doing today. We're getting together the business community along with our educators as we discuss renewable energy in new business and new home construction. Today, Mr. Bill Decker, Sr., will be answering your questions about building more sustainable homes. Mr. Decker is a pioneer in the practice of building energy-efficient homes. Over the past 32 years, he has built a reputation for his energy-efficient practices, and in 2004, Mr. Decker and Decker Homes was recognized by the State of Ohio Senator Teresa Feder as the first builder to offer the option to build a new home in Northwest Ohio, Southeast Michigan area with a solar electric system. In 2005, Decker Homes received a commendation award for energy efficiency construction from the state of Ohio and Green Energy of Ohio's Business of the Year Award. And then finally, in 2011, Mr. Decker was awarded the Eco Community Award by the Science Alliance for evaluating the environment, the Northwest Ohio Foundation for achievement in the education. His vision to preserve the environment does not stop at building homes. Mr. Decker's work at Deer Valley Subdivision highlights his effort to lead the way in environmental practices. He was the first builder in the Toledo area to create a bioretention cell. The purpose of a bioretention cell is to clean runoff water before it enters storm sewers. He has also set aside 3 lots in the subdivision to preserve the native plants and trees. Now, to participate in this live virtual field trip, you are encouraged to email questions to deckervft@gmail.com. I'll repeat that, Decker, DECKERVFT@gmail.com. Mr. Decker will be answering your questions throughout the event. This video will also be available on the Monroe County ISD website to be viewed at a later time. 5 pre-recorded mini-sessions will also be available upon request. Topics range from foundation and windows to geothermal heating and cooling. Hey, we'll be right back with Mr. Bill Decker.
Good morning. I'm Bill Decker with Decker Homes, and we're here to talk about green homes and renewable energy. The question comes up, why do we build green? We build green for several reasons, or numerous reasons. Major ones are, number one, it saves the homeowner a lot of money over the life of the home. It also protects the environment by creating less greenhouse gas emissions from burning of fossil fuels. And third, it provides more comfort. The home is very comfortable. You don't have drafts. The home is sealed properly. There are absolutely no drafts. It's quieter and just all around more comfortable. Also, it provides value upon resale, because today when people purchase homes, they want to know what the energy costs are, what the household costs to operate that home are. So those are the major reasons. We can go into each of them in greater depth at a later time, but that's the major reasons why we build green homes. We're going to introduce you to the foundation video, and we'll answer more questions then. Thank you.
I'd like to point out how we insulate our basements from the footer all the way to the top on the exterior. We have 2 inches of foam on the outside. And I'd also like to point out our basement windows you can see in the background. Those are Energy Star certified windows. You could put in windows that are less expensive with single strength glass even. But every surface and every window counts. And it all impacts the energy flow, and that's how we, by using our system, we are able to produce homes that reduce energy costs by 50%. Our average 2,100 square foot home will cost the homeowner about $100 a month to operate the home. That's heating, cooling, electric use inside the home, all utility costs, about $100 a month. And we have plenty of references for that, people living in this area, that we collect their energy bills once a year and verify what we're saying.
Yes, I have a question. Do you do any research about the land before you start digging the foundation? The question is yes. We build on various sites, off subdivision sites, rural sites, and the first thing we want to look for is drainage. Where do we drain the land? The water runoff that's after the house is much greater than the land by itself, because now we got all the roof runoff. And we want the house to be at an elevation that is high enough where it's not in danger of being flooded in a severe storm. So we're concerned about elevation, concerned about soil type, whether it's clay or sand, whether it's rock. We do a complete investigation, and we go to great care again to make sure that property is drained so that the house is in danger of water penetration in the basement. It's important to insulate the foundation on the exterior, because number one, there's only one chance of doing it when you build the home. You're not going to dig up around the house later to insulate a foundation. It's very difficult and expensive. And 25% of the heat loss in a home will go out through the basement walls if they're not insulated. It's the number one question that you'd want to ask a builder if he does insulate the basement. If builder says that they don't because the ground temperature is 55, then they don't have a clue about energy efficient construction. That would be your first step. But we insulate all our basements, and then we backfill for water penetration. We backfill with stone and sand, and of course before we backfill, we completely waterproof our basement with a heavy tar material that's sprayed on. But the best way to have a watertight basement is provide good drainage. You don't backfill with the type of soil that's on the site generally, especially if it's clay. You bring in stone about 3 or 4 feet high, and you top it off with sand, and you have the basement elevation, and your grade set so that the water runs away from the home, not towards the home. If you look at a lot of the homes that are out there, you'll see the older homes, they didn't pay much attention years ago to elevation, and the houses are too low in many cases, and you end up with water running towards the home, and that's going to cause a problem in itself. Now we're going to introduce you to the insulation video, and we'll talk more later.
Today we're going to talk about construction of single-family homes. As most of you know, that buildings in the United States consume about 40% of all the energy produced in the country, 70% of which is electricity, and most of that electricity is produced by coal-fired power plants. So we need to save energy for cost reasons, plus environmental. Today we're going to show you how we construct our homes at Decker Homes to be 50% more efficient, and part of that is because of the way we frame our homes so they can be insulated to the maximum that's possible. So I'm going to point out different features of our home that allow us to do so, and it's a matter of training the framing crew, the carpenters, on construction techniques, and it's not difficult, it's not rocket science, but it's got to be done as a whole system of the whole house, and it all works together to come up with a house that's 50% more efficient than the average home that's built prior to 2000. We'll start with how we frame our homes. Here's an example right here of how we have what we call a open corner, so you can insulate behind it. That's called a two-stud corner. Some builders call it a California corner. But you can see how we can insulate right behind. And again, we're trying to get at all these places that are hard to insulate, hard to get at, and this is one of them. And right up above you, we have what's called a raised rafter plate. I'll point to that. The raised rafter plate, this rafter up here would normally come down on this plate right here. We've raised it up so we can insulate this area right here very thoroughly, and this is going to be foam. In our next session we'll cover insulation, and you'll see that this is all foam up in here. This header will be formed. This is called the recessed header. Most headers would be flush, so you couldn't insulate them. This is recessed, so we can foam over the complete header. And then we come to our window, where carpenters are instructed to frame the opening for the window to allow a minimum of ½ inch all around the perimeter, so we can foam this and seal this. And here you can see we have a gasket seal, which is for air and water penetration. We want no air or water to get into this window area, this cavity. And again, we're foaming all around the entire perimeter of the window. And then over at this area here, we have, this is called a standoff wall intersection, where we now can insulate behind. Normally the carpenter would take this frame member and put it right against the stud. So by leaving it offset, we can insulate again that hard to get at area. Another thing I might point out, you can see this.
So what is R value? Well, all insulation materials and building materials are rated according to resistance to heat flow. That's the R for resistance. Resistance to heat flow, the higher the number, the better. For example, we install in our walls an R15 insulation fiberglass bat and a stud, a 4-inch 2x4 stud, is an R4. Generally, wood is an R1 per inch. So 20% of the wall, if it's not covered as we do with a complete thermal break with foam insulation on the exterior, you'd have an R4 on 20% of the wall. Now we're covering that all, as I will mention in some of the conversation and questions. But it's very important that you use the highest R value, and that includes windows, which we'll talk about later. So why do we use the multiple types of insulation? The multiple types that we use are foam, fiberglass, insulation. And we use foam because the foam that we use has a expansive adhesive quality. So when it's sprayed in, it expands and seals every minor crack and crevice, and which fiberglass will not do. You either have to foam it or caulk it somehow. It's very difficult to caulk hard to get at areas. So the spray foam accomplishes two things. It seals and it has a high R value. And again, we're using it in the hard-to-get-at areas that have different materials coming together that expand and contract at different temperature levels and humidity levels. And if they're not sealed properly, you'll get air infiltration and your house won't be tight and it won't perform as you expect. The next question I have is is spray foam bad for the environment? That's a very good question. And at the present time, the EPA on their website states that foam is, if it's installed properly, and that's very, very important, to be installed properly, and the applicator be certified. Most manufacturers of foam products will not sell the product to a company that doesn't have certified installers. They make sure that they're certified by themselves, the manufacturer, and then most companies will internally certify their own employees. And that's what the company does that we use. So we have certified, qualified applicators, and it's installed properly, and the EPA says that it's chemically inert if installed properly. They also go on to say on their website that they haven't studied it long enough to draw a 100% conclusion, but at the present time, it's regulated as chemically inert and it provides no hazard to the atmosphere. And as of course, neither does fiberglass. Can a house be too tight? Question, and some people think it needs to breathe, and they're right. The slogan we use in the building industry is we build tight and insulate right. Excuse me, ventilate right. We insulate right and build and ventilate, and so you do that by what we have. We have a passive ventilation system, consists of an air vent that goes out to the exterior, and whenever either the geothermal fan comes on, there's a forced air system, or if you have a gas furnace, whenever your fan comes on for air conditioning or for heating, the passive vent opens by that pressure, that fan going on, and allows cold air to come into or outside air to come into the cold air return, where it's either filtered and heated or cooled. So yes, it does need to breathe. We need to make sure the occupants have proper household atmosphere, and we do ventilate very carefully and also have a passive outside air intake to make sure we got enough fresh air in the house. Another question I've been asked is, does building green homes take longer and cost more to build? They don't take any longer to build than a conventional home. They do cost a little more, but the cost is more than offset by the lower energy cost. Generally, for every dollar you spend to improve a home's energy efficiency, you'll get $2 to $3 back in lower heating costs. They usually will cost 2 to 5% more, and then when you add renewable energy systems like geothermal and solar electric PV on the roof, either solar panels or solar shingles, that does raise the price of the home additionally, but both of them have their benefits. Number one, the geothermal system is about 20 to 50% more efficient than a standard high-efficiency natural gas furnace. And of course, if you provide enough solar on the roof, you can operate your home down to zero, where you have no bill. I'm going to introduce the geothermal video now, and we'll talk a little bit more about that later.
We're going to spend a little time talking about our heating and cooling system, which is geothermal, and how it operates. This is a geothermal system. This is a product made in Fort Wayne, Indiana, here, another U.S. product. And this technologically is the best geothermal system in efficiency in the world, made right here in America. It has a coefficient of performance of 5, which means for every 1 unit of electricity it takes to run this system, you get 4 units of heat out. And that's the highest in the country, and actually in the world, for a residential system. The efficiency of the air conditioning side is triple what code is today for air conditioning, which goes by what they call a seasonable energy efficient ratio, known as SEER. And most air conditioning going into new homes today has got a SEER value of 13. This has an SEER value of 40. So about triple in efficiency on the air conditioning side. And this runs anywhere from 20 to 40% more efficient on the heating side. In a home that's efficient as ours, where we've taken the energy load down so low, this would be about 20% better than a gas furnace. But the beauty is, there's no combustion, there's no products of combustion. It can leak into your household atmosphere if you got a cracked heat exchanger or some other problem with the furnace. This is strictly a technology that we're taking heat from the ground, bringing it into the house, and it's purified. The air is purified and conditioned. It's got a MERV filter in it that gives you a MERV 11 rating, which is like an electronic filter. And it's quiet. You can barely hear the fan running right now. We have the fan running on a continuous basis, and you can hardly hear the sound. We only have 3 moving parts. This pump, which pumps a glycol, it's a water glycol solution into the ground, and circulates it around through the pipes in the ground, brings it back in where it enters into the unit, and the unit sends this to your register at 100 degrees. And to get into that technology, it gets a little bit of physics, a little more detail than I can get into on this demonstration, but it's great technology, and it works beautiful with solar. Because now if we power the house with solar, we can get to net zero. And we will show you that technology on another house that's got heating and cooling or operational cost of less than $25 a month with the solar system in addition to this geothermal. Most of our customers, or at least half or more, are electing to go with geothermal, and then some are adding solar. But the day is coming where, as this technology continues to evolve and get better and better, where I can see the day where this will be standard. This will be so economical and so efficient that it wouldn't make any sense to put in a gas furnace. It also heats the hot water. Here it does about 60% of the hot water. Here you can see the line from the unit going into a storage tank, and then from the storage tank into the hot water tank. And the unit heats about 60% of the hot water. And that can get down to zero with a little hot water solar system on the roof. We could do 100%. And that will evolve also. So we highly recommend that you research a little into geothermal. And this is manufactured by Water Furnace, again, Fort Wayne, Indiana. And their website information and videos and all about this product, which again is best in the world.
A question from Mr. Brighton in Whiteford. Why don't we spray the entire house with foam? And the major reason for that is we can find no distinguishable difference between fiberglass and foam when it comes to our efficiency of our home. And foam costs more, so we're trying to build the most efficient home for the least amount of dollars. And that's been a 32-year endurance equation. We've always paid attention to cost-value relationships, and we've done computer modeling for years. We had a big advantage of Owens Corning, who had computer technology back in the 80s, and we did a lot of computer modeling, and we since have continued. We monitor our homes, and about 3 years ago, we built 2 identical homes which were being purchased by 2 retired couples, and one went with foam, the whole house with foam, one with fiberglass, and again, we do use some foam for those hard-to-get-at areas. And after we tracked it, after they were both living in the homes for a year, they were block apart, same orientation, 2 people, couldn't have a better test. we could find no distinguishable difference between the foam and the fiberglass, and the foam costs considerably more money, about double. We're convinced that we're doing the right thing, that if we want to add the weakest link in that wall after everything we've done is now not the wall itself, it's the window. Our wall is about an R20, and now we have windows that were 3.3 R value. So we now are promoting a R5.9 window, triple pane, to raise that weakest link in this chain, which is our windows. So that's basically the reason why we don't use foam in the entire house. We'd rather put it in the weakest link, which is the window, the extra dollars. How long, I got another question from Mr. Brighton from Whiteford. How long does geothermal last? Well, they're guaranteed for 20 years. The pipe in the ground is guaranteed for 50. And generally, they only have 3 moving parts. They don't have a heat exchanger. They generally should last 50 years. There's systems out there that the company that we use to install our geothermal, they've had systems out there for about 35, 40 years, and they're still operating. So the longevity on geothermal is definitely longer than a natural gas fossil fuel-fired furnace, and the popularity of the installations are growing. People are now coming into our models asking about geothermal. When we come to our office inquiring about building new homes, geothermal is now very much wider known than it was 5 years ago. We build about 40% of our homes. It's an optional upgrade, and about 40% of our customers are upgrading to geothermal, and about 10% go from geothermal to solar on the roof to produce the electricity that the house uses on the roof, and trying to get down to that net zero energy bill. Yes, again, the geothermal is it's great technology. It's easy to talk about with a customer because of the benefits. And I can see, again, that as I mentioned in the video, the day is coming where we won't be using natural gas in our homes. Why is geothermal better to use than natural gas? Number one, natural gas is a fossil fuel. It does reduce the emissions compared to coal, 50%, but it's still 50%. And you have you don't have the danger. If you go on your computer and Google natural gas explosions in the United States, every week somewhere in the country you got somebody blowing up a house with natural gas, because maybe they're careless. If you talk to firemen, they'll tell you that people are careless around their hot water tanks, their furnaces, they're cleaning brushes and turpentine, and they cause an explosion, or they got workmen out there doing some work nearby and they cause an explosion. It's as safe as it can be, but it still has that ultimate factor that geothermal does not have. You're never going to get carbon monoxide poisoning with geothermal because you don't have a heat exchanger. You have no flame. It's free. You don't have any fuel. You're getting your heat from the ground and transferring it into the house. It's amazing, great technology, and it's becoming more and more efficient, more economical each year. There's more breakthroughs in the technology, meaning they get more efficient, so you get more out of each unit of electricity they use to run that system. We've also been asked, how do we use solar technology in our homes? Well, let me just say that I want to mention that homes in this country consume almost 40%, about 39% of all the energy in this country is used in buildings. Homes use about half of that, the other half is commercial. Take your school, for example, churches, big buildings, malls, and we have over 100 million homes in this country. So homes or buildings combined are the biggest energy consuming category in the United States and basically the world. Transportation is only 28%, and manufacturing is only 33%. But if you ask most people what segment of the economy uses the most energy, they'll probably say the automobiles. Anyway, that's we're going to talk about the finished project video, and we'll talk answer your questions after that.
We're going to talk a little about the new window technology that's only been available for the last couple years. And this is a new window manufactured by Pella, and it has a 5.9 R value. The U value is 17, and the R value is a reciprocal of U value. If you divide that into 100, you'll get 5.9, which is really revolutionary. Up until now, most windows are 3.3. Energy Star only requires a 3.0 to qualify, and this is more than double. These are triple pane vinyl windows made here in America. The grids are in between the glass, so you don't have to worry about breaking grids or taking them out to clean. And the windows are really the weakest part of the wall. If you have windows that are inefficient, 20% of your wall is going to be inefficient. What we want to point out, an energy efficient home doesn't look any different. It just performs differently. It performs much better. And we'll start with this finished home. This is a 2,300 square foot ranch. Has a HERS rating of 38, which HERS is a home rating energy service where every one of our homes, an outside technician comes in and does lower door testing and inspection, and takes a lot of notes every appliance, how much energy they use, puts it all in a computer and comes out with an estimated heating cost and gives you a rating. Our rating on this home is 38, which means we're 62% more efficient than an average home of this size built today. It starts at 100. When you get to 0, that means you're a net zero home. You don't have a bill, and we're close to that on one house ourselves. But this is a high-quality home. The average person that is interested in energy efficiency, of course, also wants a high-quality home. And we'll point out that we do have a fireplace. This is a gas fireplace. It's the only appliance in the house that's not electric. The whole house is electric. It's got a
I have a question from Mr. Russo in Bedford. How can we be greener in a pre-existing home? There's a lot of things you can do in a pre-existing home. Number one, take a look at your basement. You can insulate the inside of the basement by studding up the walls and insulating, either with foam or fiberglass. And the band joist directly above your basement wall between your first floor and the top of your basement foundation is very, very high area of air infiltration. That should be foamed. Just tighten up the house. Make sure you plug every hole you can. Look around where your air conditioner line comes out through the wall, any electric lines, plumbing lines going out through the wall. Make sure they're sealed. And if you need new windows, buy the best ones, and that would be triple pane. And just pay attention to all those little details, and you can do a lot to insulate, to actually improve the energy efficiency of an existing home. Where you start is you start with an energy audit. You have a certified energy auditor. Again, all you have to do is go on Google and punch in energy audits, and you'll see that there's different companies come up that do that. And utility companies, Consumers Power and Detroit Edison, both do energy audits, as does First Energy in Ohio. So that would be the best place to start, and then go from there. I have another question. What is a net zero home, and what does it take to build one? Well, a net zero home is a home that produces as much energy as it consumes. It produces it by a solar system on the roof that produces electricity. What a solar system does, a solar electric, also called solar photovoltaic, it converts sunlight into electricity. So you have if you have a geothermal system, which is an all-electric system, you have an all-electric home, and you're producing the electricity on the roof. If you have a well-insulated, green energy constructed home, you're going to get to net zero. Believe it or not, if you go on and punch in net zero on Google again, There's literally thousands of net zero homes being built in this country today. I was at a seminar myself in California just a month ago and looked at numerous homes out there that are net zero. And you have one in Ann Arbor, you have a 110-year-old existing home that was converted to net zero. All this is on the web. And you have a real big benefit here in Monroe. And also people from Toledo and Bedford should visit the IHM Mother House in Monroe, the Immaculate Heart of Mary Mother House in Monroe. It's a highly energy efficient 400,000 square foot building, has geothermal. They also have a solar array that they recently installed in the last year. And this is a 75-year-old building that was retrofitted by these sisters. They're remarkable. You have a great example here right in the community, and they have tours. Actually, it's open 24 hours a day. You go through and they have a complete self-tour that you can go in and see all the exhibits and how they've done it. And there are other assets. You have a new net zero school in Lenawee County, actually intermediate school district, that they have tours where the school is net zero. So this is not uncommon. And I will predict that many of the students watching this video and seminar today are going to be buying homes in 10 years that are net zero. And we hope that we'll be building many of them. What other ways do we promote sustainable living? Well, we do that by reducing our effect on the environment, by what we did in our subdivision when we develop land. We develop land and build and do both, and so bioretention cell to clean the water before it leaves the site and it goes into quick clean. And also we look for natural features of the land that we develop that are worthy of preservation. And it's a broad spectrum. It's every facet of your life, whether it's recycling, taking your cardboard and papers to the recycle bin, and watching what you throw away and try to recycle what you can. And it's something that you do that many of you are doing a lot of that, I know, because it's, I have a granddaughter that's in the 4th grade, and I see what she brings home, and I'm very encouraged by the amount of green education that our schools are giving. What do we see as the future of green building? Oh, it's definitely, there's no turning back. It's the wave of the future. It's what the new 21st century builder will be doing or is doing if they're on the leading edge. And I should say it's no longer leading edge. This is right now probably a third of the homes being built are green in some fashion. By green you mean you start at 30% more efficient than the average new home being built. And our homes are, most of those are 50% and higher. I mean, like I mentioned earlier, we have one that's almost 100%, and we hope to be building a net zero model very soon. So I appreciate the being here today with you, and I applaud the Monroe Intermediate School District for hosting this event. We are happy always to talk about building green. We do have a model. You're always welcome to come to our model. It happens to be in Monclova, and we're always the future of this is very optimistic for me, because I've been doing this for 32 years, and in most cases it wasn't very popular because it did cost more, but the fuel wasn't as expensive as it is today. So we're very happy to talk about it and encourage you to go on Google and look up a lot of these. There's just a tremendous amount of information on the internet. All you got to do is Google it, and you can learn anything you want to learn about building and building green. So thank you very much. Pleasure to be with you here this morning, and hope to see you at our model home sometime.